Hello everyone, Mr. Wendell here. Today I'd like to take a look at the conservation of momentum equation. Over the past couple days we've taken a look at calculating momentum. You've done a lab 6C, that looked at the idea of conservation of momentum, and we compared the speeds of the cars and the masses of the cars when they hit each other and the result. So the initial equation for us is momentum equals mass times velocity. Now what we're going to do is we're going to take a look at what happens when one object hits another object and transfers its momentum. So let's start out with an ice skating rink. And the reason I'm going to pick this is because the surface of the ice is basically frictionless. There's not too much friction there. You can slide for a decent long way. So we've got person number one. You're going to have to excuse my pictures. They're generally pretty bad. And we have another person standing over here. There we go. Person one weighs 50 kilograms, and they're moving at 2 meters per second. They're going to go ahead and skate down the ice skating rink, and they're going to run into the second person. So that second person, we're going to say that they weigh 70 kilograms, and we want to find out, well, what is going to be their velocity after the interaction. All right, so the momentum of the first person is going to be equal to the momentum of the second person if momentum is conserved. And we're going to say that it would be conserved in this case. So when we write the equation, momentum 1 equals momentum 2, and you can break that down to mass 1, velocity 1 is equal to mass 2, velocity 2. Okay, because momentum is mass times velocity. So for the person on the left-hand side, we're just going to rewrite this. So mass 1 is 50 kilograms, and the velocity, the first velocity, is 2 meters per second. That's going to be equal to the mass of the second person, or m2, 70 kilograms, times the velocity of that person. And what we're trying to figure out here is, what is their velocity after they get hit? So we'll start to do the equation. So this is going to be 100 kilograms meters per second equals 70 kilograms v. Algebraically, next step for you is we're going to divide by 70 kilograms. That crosses out the units here. Divide by 70 kilograms on the left, and that will cross out the units. We're going to be left with meters per second. And when you calculate this out, we have 1.428, but we're going to round that. So this is going to be 1.4 meters per second is equal to the second person's velocity. So hopefully this helps out a little bit in calculating your conservation of momentum equations. The worksheet that I've given today has some equations that are just calculating momentum of an object, and some others where you have some interactions between two objects. If you have any questions, please make sure you email me, or you can let me know via Google Classroom, and I would be happy to help you out. Good luck!